Okay, in this question, we've been given the image, so we know straight away we're working with connected particles on inclined planes. A fixed rough plane is inclined to the horizontal at an angle alpha, where tan alpha equals 4 over 3. This is going to be useful later on. A small, smooth, light pulley P is fixed to the top of the plane. A particle A of mass 2m and a particle B of mass m are connected by a rope. The rope passes over the pulley. The part of the rope from B to P is parallel to a line of greatest slope of the plane. Particle B is held at rest on the rough plane, and A hangs freely with the rope taut, as shown in figure 1. Particle B is released from rest and begins to move up the plane. As always, I'm going to want to make my own diagram so that I can label it fully, knowing that there's no forces that are missing and everything that I need to work with can be annotated and seen clearly. So I'm going to go ahead and do that, including a lot of the forces which aren't initially shown. So there's my particle. I'd rather draw it as a box, and here's my hanging box just to help with the labeling and the direction of some of the force arrows. So we have some weight for each of these particles. Since they're connected by a rope, there is tension, and we know that there's friction because it's a rough plane. If the box on the slope is in contact with the slope, there's a reaction force, and we know weight has some components. Okay, let's just label up everything we were given in the question. What we weren't told in the question is what these components should be. Let's just get in the alpha, and the angle here is also alpha. This perpendicular component is mg cosine alpha, and the parallel component mg sine alpha. This is the direction the particles are going to be moving. Okay, we were told that tan alpha equals 4 over 3, so let me quickly get sine alpha and cosine alpha in fraction form as exact values. Okay, I think we're ready to start. The question has asked us to find, in terms of mg, the magnitude of the normal reaction that the plane exerts on B. So we're looking for R, the normal reaction force. So we're going to resolve perpendicular to the plane. There's only two forces involved, R and mg cosine alpha. Since the particle is not moving in that direction at all, we know that R equals mg cosine alpha. And luckily, we have a fraction for cosine alpha, so we know that R is 3/5 mg. We're told that the rope is modelled as being light and inextensible, and as B moves up the plane, the tension in the rope has a magnitude of 7 over 5 mg. The coefficient of friction between B and the plane is mu, just like we always expect. We've been asked to use the model to write down an equation of motion for A, and to find in terms of G the magnitude of the acceleration of A. Okay, so all of this we're going to do thinking about the direction of motion. So, resolving vertically, we're going to get, using Newton's second law, that 2mg minus t is going to equal 2ma. We've already been told that the tension is 7mg over 5, so we can substitute that in. 2mg minus 7mg over 5 equals 2ma. And really, this can be rearranged. We just need to be sensible about how we combine them together. I'm going to write the left-hand side as a fraction over 5. That gets us 3mg over 5 equals 2ma. The m's can cancel, and we can rearrange to make a the subject. So we get 3 over 10g for the acceleration. Okay, so from the equation for motion all the way through to the acceleration of A, which is also the acceleration of B. Part C says we should find the value of mu. And since mu is friction, we're going to use a motion equation by resolving parallel to the slope, the direction that the box is moving. So, resultant force, tension, minus friction, minus the parallel component of weight. So that's 4/5 mg. All of that equals ma. We know what t is, we know what r is, and actually we know what the acceleration is. So we're just going to substitute all of those expressions in, and then we're going to go about trying to simplify. The quickest way I can see to simplify is just to multiply through by 10. Let's get these fractions out of the way, multiply everything by 10. That gives us 14 mg minus 6 mu mg minus 8 mg, and that equals 3 gm. We've got m's and g's in every single term. They can be cancelled out. 14 minus 6 mu minus 8 equals 3. And that looks so much simpler than what we started with. Just by being patient and seeing what we're working with and taking sensible steps. Now we've got negative 6 mu equals negative 3. Mu is going to equal a half. The coefficient of friction in this question is 1/2. We're told that in reality, and we know this, a rope is not going to be light. We're asked to state how this would affect the tension in the rope as we've modelled it. Well, because the rope itself is not light, in some cases the rope is going to need to hold the weight of some of the rope hanging underneath it. So the tension in the rope is not actually going to be the same all the way throughout. We've made that assumption to work with our model to make a sensible prediction, but the real world situation is not going to have the same tension all the way through.